You're welcome to Unified Academy tutorial. Okay, and this tutorial is calculus. Precisely, the topic we are considering in this lesson is the ideas of integration. The ideas of integration. Okay, so the textbook where the contents are majorly gotten from is Pure Mathematics by Bondi. Okay, Pure Mathematics by Bondi. Now, so let's look at the introductory part of it. The introduction. Okay. Now, when we're talking about integration, what are we referring to? Okay, it's just like a reverse differentiation. Reverse differentiation. Okay, so that's just like we are trying to reverse the order of differentiation. But what do I really mean in that sense? Now, imagine that you have a function whose ddx gives g of x. Okay? Now, in this case, you see that ddx of f of x is g of x. Okay, so g of x is also a function of x, but the derivative of f of x gives us g of x. So how can we find f of x? To find f of x, we are going to use the process called integration. We want to integrate it. So just say that write f of x to be the integral of g of x dx, and that will give us f of x. Okay, so it is the integral, so that this is the integral of g of x dx. Okay, now for example, now if the derivative of a function ddx of a function is cos x, what would that function be? Definitely that function should be sin x. Okay, that function should be sin x. That means ddx of sin x gives us cos x. So to get that, we are saying that sin x is integral of cos x dx. So this process is integration. Okay, we are trying to find the function whose derivative is cos x, and that function is sin x. Okay, alright, so that's like an introduction to what we are doing. Okay, so we call this process integration. Okay, so that's like integration. So let's look at definition now. So in definition, the integral of a function, g of x with respect to x is the function whose differential coefficient with respect to x is g of x. and it is written as integral of g of x dx. Okay, so that's how to write it. Now, so we're saying that the integral of a function g of x with respect to x is the function whose differential coefficient with respect to x is g of x, and it is written as integral of g of x with respect to x. So that's integral of g of x dx. Okay, so that is we are integrating with respect to x. So once you see this kind of integration sign and you see the letter that is here, that is we are integrating with respect to this derivative, which is x. Now let's take an example to explain that. Okay, integral of sin x dx is now equal to minus cos x. Okay, now what does that mean? That means when you differentiate this, you are supposed to get sin x. When you differentiate this, you're supposed to get sin x. And imagine you differentiate minus cos x, d dx of minus cos x. It gives you, let's bring out the minus, you have d dx of cos x, and then to the minus d dx of cos x is going to give us minus sin x, and that will not give us sin x. So that means if you differentiate this, you have to get sin x, and then if you integrate sin x, you have to get cos x. Okay, so that's what that is explaining. That if you differentiate, if you integrate sin x, you are going to get minus cos x, and then if you differentiate minus cos x, you are going to get sin x. Okay, so let's proceed. So integral of cos x dx will give us sin x. Integral of sec square x dx is going to give us tan x. Now, why is this so? Because when you differentiate tan x, you are going to get sec square x. So then that means when you integrate sec square x, you are going to get tan x. So that's what it is. Okay? Now, there is another one. When you differentiate d dx of ex, is equal to ex. Okay? So that means when you integrate ex versus x, you still get ex. Okay? And then when you differentiate in x, you're going to get, that means in x is the same thing as natural log. Okay? The same thing. So when you differentiate it, you're going to get 1 over x. That means when you integrate 1 over x dx, you're going to get in x. Okay? So just take note of that. Now, so we're going to look at this arbitrary constant. And what does this arbitrary constant refer to? Now, recall that the derivative of a constant, the derivative of a constant is 0. Okay, so if c is the constant, then d dx of c is going to be 0. That means when you have y, the function y, okay, if it's something like 3x squared plus 5x plus 6, then y dx is going to be 6x, okay, plus 5, and then this one is going to be 0, okay. So that is the derivative of c, which is a constant, is going to be 0. Now that c in a function it may exist, but when it comes to integration, you may not be able to know what that c is, except you are given some information. So in this case, we are not going to say integral of 3x squared dx is a function whose derivative, the integral of 3x squared dx is 3x 2 plus 1 over 2 plus 1 plus 6, and that gives us 3x equals 3 divided by 3 plus 6, and that is x equals 3 plus 6. Why we are adding plus 3 is because it is possible for us, because this integration is telling us that the derivative of this is going to give us 3x squared. That's what we want to find. So we want to find a function whose derivative is 3x squared, and this is the function. Here c is an arbitrary constant. It can be any number. If it is a number, by the time you differentiate this, you are still going to get 3x squared. Okay? So now let's look at standard point. Some standard point. Now in this standard point, let's assume we have the following: the integral of sin x dx, this was minus cos x plus 6, okay? Integral of cos x dx, this was sin x plus 6. The integral of x squared x dx, this was sin x plus 6, okay? So, and then we still have integral of e to the power x dx, this was e to the power x. Integral of 1 over x dx, this was in x. So this was c, this was c. Okay? Integral, now take note of this. Integral of x to the power n dx is equal to x to the power n plus 1 divided by n plus 1 plus 6. Now, unlike differentiation, if this is differentiation, we are going to have x to the power n minus 1, okay? Then n will multiply it, okay? So, but this is not differentiation, this is integration. So, in integration, what we do is that we add 1 to the power and then divide it by what we have here, okay? So, furthermore, integral of 1 over a squared plus x squared dx. This can be written as, this thing can be written as dx is just as dx. You can have it that way, okay? But let's leave it like this. So, it is 1 over a as tan x over a plus 6, okay? Here is a constant. Here a is a constant. Okay? And we can also have integral of 1 over square root of a square minus x square dx. That will be arc sine x over a plus 6. Here a is a constant. Okay? So there are many functions that can be written, and then we want to find the integral. So at least these standard forms, we're able to know them by heart. Okay. So let's take examples. Let's take some examples. Okay. These examples. So do the following. Integrate 1. Integral of e power y dy. Okay, e power y dy is going to be e power y plus 3. Just know that this is a variable. It can be x, it can be y, it can be any other letter. So the variable that is here will be the one that we are integrating with. So in this case, there is y here. If there is no y here, then this function, this e is going to be a constant. But because there is y here, so e power y, integral of e power y is e power y. Now compare it with this. We observe that it's e power x. Alright, so second one, integral of the u square plus 9. This is the same thing as writing integral of 1 over 9 plus u square, the u. Okay? And then the answer here is not going to be, imagine I write it out. Imagine it is written as the integral of the u over u square plus 3 square. So that it will look like one of the standard forms, which is this. Okay? In this case now, this is 3, and then 3 is squared. Okay? So I will now have 3 squared. So here it's going to be 1 over 3 half times u over 3 plus 2. So that one I can written in form of square. Okay? So another one over 3 integral of the z over z. That will be in z plus 6. Okay? So that is just like this standard form. Because this thing here can be written as in the x over x. So we have is what we have. Okay? Is what we have. Now let's take another one. Another one here. Integral of x equals 6 dx. So now the x equals 6 plus 1 divided by 6 plus 1 is plus 3. This is x equals 7 over 7 plus 6. Okay? Another one, integral of 1 over x equals 6 dx. That will be integral of x equals minus 6 dx. That will be x equals minus 6 plus 1 divided by minus 6 plus 1 plus 6. And that will be x equals minus 5 over minus 5 plus 6. Okay? So it can be written like that. And then it cannot be written as 1 over 5x equals 5 plus 6. Now we can also have number 6, integral of cube root of x dx. Before you integrate, you write it as x equals 1 over 3 x. So you have x equals 1 over 3 plus 1 divided by 1 over 3 plus 1 plus 6. So that will be 3 over 4 x equals 4 over 3 plus 6. Okay? So we can also have So this is number 6. We can also have integral of 1 over square root of x equal 3 dx. So you have to rewrite it as integral of 1 over x 3 over 3 dx, and the integral of x equal minus 3 over 3 dx. So we add 1 to the power, and then divide it by minus 3 over 3 plus 1 plus 3, which is equal to x this power minus 1 over 3, and then minus 2. That's when you simplify this, okay, plus 3. And the final answer is minus 3 over square root of x plus 3. Okay, so just simplify and then get the answer. Okay, so another one, integral of 1 over square root of 9 minus x squared dx. Now this is compared to square root of x squared minus x squared dx, which gives us half sine x over 8. Okay, so let's compare it now. So this is integral of 1 over square root of 3 squared minus x squared dx, and then the answer will be half sine x over 3 plus 6. Okay, that's the answer. So there are different kinds of forms the question may be written. Okay, now let's take more questions. Now integral of sine square half x, that's sine square x over 2, can be written as sine square x over 2. You see the same thing. Now, but before we can solve this, let's use trigonometric identity that says that cos 2x is equal to 1 minus 2 sine x. And now compare this, you have 2x here and you have x here. That means cos x is equal to 1 over 2 sine x over 2. What happens? When we have x, we have 2 times x. So when we have half of x, we have 2 times half of x, which is x. Okay, so now let's make this the solve for the formula. So, excuse me, there's supposed to be square here. Square there. Okay? These are trigonometric identities, especially this. Okay? So, now from there, let's make this solve for the formula. We have sine square x over 3 is equal to 1 minus cos x divided by 2. Okay? 1 minus cos x divided by 2. Okay. This will now be integral. Instead of writing sine square x over 2, we will now have 1 minus cos x divided by 2 dx. And then we will now have our answer from here. Okay, we will now have integral 1 over 2 minus cos x over 2 dx, and that is equal to 1 over 2 minus 1 over 2 sine x plus 2. Okay, now mind you, this place you want to integrate because this integration applies to both of them. It applies to this. So when you integrate this, you have, let me just, I'll do it in the next place. So we have have the integral of 1 over 2 minus cos x over 2 dx. Okay, so we can have it as integral of 1 over 2 dx minus integral of cos x over 2 dx. And that will be 1 over 2x. Now, find the integral of a constant dx is going to give us constant times x plus 2 or plus b, where b is also a constant. Unlike differentiation, if you differentiate a constant, you get 0. But in integration, if you integrate a constant, you put times x. If you are integrating with respect to x, so you put times x. Okay? And then you now add another constant. So in this case, half is a constant. So I'll put x. Okay? So minus. Now I can bring that 1 over 2. I have integral of x dx. So you get 1 over 2x minus 1 over 2 times x plus 2, because integral of x is times x. Okay, so this is the answer. Okay. Now, so there are just different forms of writing in which a section will appear. Okay. So if you endeavor to know how to solve such questions. Now let's take an example. Now find y in terms of x. D square y dx square is equal to 6x minus 4. And further y equals to 0 when x is equal to 0, and the y dx is equal to 3 when x is equal to 0. Now, let's take this question. What I want us to find is y in terms of x, like writing y as a function of x. Okay? Now, and they say that this square y, the x square, is equal to 6x minus 4. So we have this square y, the x square is equal to 6x minus 4. So what we have to do here is, this y has been differentiated twice to get this, okay, with respect to x. So now we're going to integrate twice. So let's do it one by one. So we have the square y, the x square is equal to 6x minus 4. Then when we integrate first, the first integration we're going to get dy dx integral 6x minus 4 dx. So this means that this is the second derivative. So we're going to get first derivative by integrating 1. Okay? So this will be 6x squared divided by 2 minus 4x plus 2. That's y dx. Okay? And that will now be 3x squared minus 4x plus 2. That's y dx. But y dx for dy dx is equal to 3 when x is 0. When x is equal to 0. So we're going to substitute it here. Okay, so that means this one is 3 when x is 0. So we have 3 equals to 3 0 squared minus 4 0 plus 2. Okay, plus 2. So that means we have 3 equals to 2. That means 2 is equal to 3. So therefore, y dx is equal to 3x squared minus 4x plus 3. So instead of writing c, write 3 because we have gotten the value of c to be 3. Okay, so we continue with that. So divide the x is equal to 4 is equal to 3x squared minus 4x plus 3. So 3x squared minus 4x plus 3. So here we are going to integrate again because we want to get y with respect to x. So we have y now is equal to integral of 3x squared minus 4x plus 3 dx. Okay? So in this first case, we integrate to get y dx. In this second case, we integrate to get y. Okay? Now, we now have y equals to 3x 3 over 3 minus 4x squared over 2 plus 3x plus c. It's constant also, but let's call it d in this case. So this is a constant. So, and then we are told that, but y equals to 0 when s is equal to 0. Okay, from the question. So therefore, 0, which is y, is equal to 3. In fact, before that, you can write y equals to x cubed minus 2x squared plus 3x plus d. So therefore, when we substitute, we have 0 equals to 0 minus 2, that's 0 cubed, 0 squared, plus 3 0 plus d. That means d is equal to 0. Okay? And then we now have therefore y is equal to x is power 3 minus 2x squared plus 3x because d is equal to 0. So that is what they want us to find. This is y with respect to x. Y with respect to x. Okay, so let's stop here. This is Unique Class Academy. So if you have questions, you may ask a question on WhatsApp or call this number. Thank you for watching. Bye for now.